The next extension we'll discuss is stored procedures. Stored procedures and UDFs can sometimes be confused with one another because they are both essentially callable routines that execute programmatic logic. And as you can see, the syntax and structure are very similar. However, the distinguishing characteristic of stored procedures is that they can include SQL statements. So, not only can stored procedures execute logic, but they can actually manipulate your data and tables as well. Stored procedures in single store can execute virtually all DML statements, and that's data manipulation language. So, of course, select, insert, update, and deletes, as well as all other DML statements, with the exception of explain and profile. Stored procedures can also support a large number of data definition language statements like creating, altering, and dropping tables, and much more. And it's always the best idea to check the documentation for what DDL statements are currently supported, as we are continuously adding more and more with every ship release. So here is an example stored procedure where we are charging a bank account with some variable amount. So we can see in the declare block that we define a few variables. First, we define a variable called balance table that will be of type query and will hold the following select statement, which, as you can see, retrieves the remaining balance of this particular user's account. In the next variable called balance, we pass the query variable into a scalar function, which simply executes that query and returns a single value, in this case, a decimal. Then the third and final variable is just the updated balance, which is the balance subtracted by the amount, and hopefully this is a positive number. Then in the body of our procedure, we see a simple if statement that asks whether the balance in our account is greater than the amount requested, and if it is, we execute an update statement which sets the remaining balance column in our table to the updated balance. And as you can see in the bottom corner, we can invoke stored procedures using the call statement instead of select like UDFs. You can invoke stored procedures in a couple of different ways. The way that we just saw using call ignores the return value. So if you have a stored procedure that just needs to execute something with no return needed, you can use call. Echo, on the other hand, does return either a scalar or query type result. Echo selects are used within the body of the procedure and can be used for a number of different reasons, but primarily for multiple result sets and also for debugging. When debugging a stored procedure, an echo select can be used like a print statement that outputs to your console. Exception handling. So exceptions are basically additional backup instructions that specify what to do in cases of errors during execution. There are two types of exceptions that can be raised: internal and user-defined exceptions. Internal exceptions are predefined errors from single store that might be raised, like syntax errors, connection errors, or insertion errors, like perhaps a duplicate key error. Users can also create their own custom exceptions. For example, you can define an if statement that raises an exception if a certain condition is not satisfied. The user exception function accepts a string that will serve as a message identifier for that particular exception. So here's an example of a stored procedure with an exception clause that catches an internal exception for error duplicate entry errors. Now we define a table called T that we'll insert into, and another table called T errors that our exception will push into if our error is raised. So if we run the second insert statement on the right, single store will bounce back with a duplicate entry error, but if we call our stored procedure with the same data, it will raise the exception and insert the duplicate data into the T errors table. So let's recreate this example in Studio. So first we'll create our two tables: T that stores our data, which will have two columns, an ID, which will make the primary key, and a string column. And then the T errors table, which will be populated by our exception handling, will store the ID and the string of the error, as well as the date and time in which it was processed. So let's create our stored procedure. First, we'll change our delimiter. Then we'll create procedure insert handle exception, which will accept the ID and the string. We have no variables to declare, so we can begin our procedure body. Now, at this point, we'll just write the code that handles inserting into our T table. So we'll open a transaction, insert into the T table, and commit this transaction. So if we create this stored procedure, then call the procedure with an ID of 1, the procedure should execute successfully. And just for good measure, we'll call it again with an ID of 2. So if we query our T table, we'll see that our data has successfully made it into our table. Now, if we try to run this procedure again, but with a primary key that already exists, we should get an error. So here we see an error duplicate entry exception that is raised, and for good measure, we don't want duplicate primary keys. So if we wanted to catch these errors without our procedure failing, we could write some additional code to handle this exception. So within the body of our procedure, we'll use the exception keyword. And the syntax we want to use here is when error message then. So as we can see below, our error name is error dupe entry. And at this point, much like a conditional if statement, if this error is raised, we will execute the logic within this block of code. So the first thing we'll want to do is roll back the current transaction and start a new one. And instead, we'll insert into the T errors table. So we'll quickly add in the or replace option in our create statement to overwrite this procedure. And let's try that call statement again and see if our procedure fails. Great, so we can see that no errors have halted our procedure, so let's check our T table to make sure that the bad data hasn't somehow made its way in there. Great, so let's check our T errors table, where that data should have been inserted instead. Excellent, so our exception handling caught the duplicate entry error and inserted into our errors table instead. Now, at this point, if you wanted a little more visibility and messaging in how your procedure is handling the data, you can always throw in some echo selects to print out some messages. For example, we can add at the end of our exception block an echo select that prints a statement that lets us know that this error was raised and handled. So now if we call our procedure with duplicate IDs again, we'll get a message that lets us know that an exception was raised, so we know how our data is being handled.